Okay, hello there, Zach. We are going to do lesson number 53 today. Lesson number 53 is going to be super fun. I think you're really going to like it. It goes over the power rule for exponents. And the reason I've got Donkey here is because I'm going to call it the parfait rule. P-R-F-E. Parfait. Everybody loves a parfait, right? So we're going to call it the parfait rule. And basically, we're going to derive it. So it's going to be great. And then, do you know what derive it means? It's going to basically explain how this rule came to be, why it is a true rule. I'm not just going to teach you the rule. That would be for dummies, you know? If I'm like dumbing this down, I would just teach you the rule. I'm going to teach you how to make the rule. If you forget the parfait rule, you will be able to come up with it as if it were a new rule. And it'll make total sense. You're going to love it. Okay, then we're going to go over how to convert volume. So you know how you convert areas like length from inches to feet or whatever? And if you convert area, then you have to do it twice because it's a square, you know, an area squared, right? So it's going to be inches to feet squared, inches squared to feet squared. Now we're going to do volume. Volume is cubed. It's 3 times. So 3 times the fun. We are going to have a lot of fun today. Math. The only place where people buy 64 watermelons and no one wonders why. Sometimes the story problems are a little like that. But anyway, all right, here we go. The parfait rule. Now, it gives a quick review on some of the definitions that we have used with exponents. So this is the first definition right here. If you have x times x times x times x times x to, you know, dot, 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 like to infinity, and there are m factors, and then m is the number of x's that you have, then what you basically have is x to the m. Right? So that makes sense because if you have 3 x's, it's going to be x cubed. If you have 4 x's, x to the 4th. If you have 10 x's, x to the 10. If you have m x's, it's x to the m. And of course, m has to be a natural number. We're going to get into stranger numbers later on. So just for now, remember that it has to be some sort of natural number. Can't be an alien number. Now, the product rule. The product rule for exponents means what do you do when you multiply 2 things together? Because product, of course, is the name of the answer that you get when you multiply. So in this situation, x times n times x times n, right? N is in Nancy. So what do you get? You get x m plus n, x to the m plus n. So you just add the exponents. So you know that already, right? So this is like fairly self-explanatory. If you have x squared times, whoops, what happened there? Let's get rid of that. Okay. If you have x squared times x squared, you're going to end up with x to, I don't know why it's doing that. That's so annoying. Oh my goodness. Okay. Let's see, let me make it smaller. x2 plus 2 or x to the 4th because you just add the exponents. So easy peasy, you know how to do that. I shouldn't have used that example because if you multiply 2 times 2, you also get 4. Let me do it with another example. Yeah, you're gonna like this better. Okay, so x to the 3rd times x to the 4th, and you get 3 plus 4 equals x to the 7th. Okay, easy peasy. And of course, as x has to not equal 0. All right, here's another definition. So this, again, just another review. X to the 1 is just an x. Okay, and here's another definition. X to the negative n means you flip it to the bottom and you change the sign on the exponent. So let's do an example there just to remind you. X to the negative 3 is going to be the same as, hey, move out of the way for a little bit there. Okay, x to the negative 3 is going to be the same as 1 over x to the 3rd. Okay, you know that. We've been doing that. You got it. Here's one more definition. X to the 0 is equal to 1. This is my favorite one because when you see that, anything raised to the 0 power, you can just basically cross it out. It's a 1. Unless it's like at the end, you've got like x, p, m plus x to the 0, then you can't cross it out because you've got a plus 1 on the end, right? But if it's like mixed in here, you can just cross that out, right? Okay, cool. So now the quotient rule. The quotient rule, remember, quotient is the answer that you get when you divide. So in this situation, you've got an x over an x to the m over an x to the n. So what do you do in this situation? Well, it's sort of the opposite of multiplying, right? When you multiply, you add the exponents. When you divide, you subtract the exponents. And we derived that one before, so I think you know why you have to do that, because this is basically on the bottom and you change the sign, right? You could do it to the top and then do a negative n. And then if you add those exponents, because now it's multiplication, what do you do when you add the exponents? You get m minus n. So there you go. I just derived it again for you. So you get x to the m minus n. That's the quotient rule. So you basically subtract this and this. Now, what if you wanted to put this on the denominator? Well, it's easy. You just change the signs of those. And changing the signs would make it essentially n minus m, because you would have a negative m plus n. Negative m plus n is the same as n minus m. So easy peasy. I think you understand that. Of course, x has to not be 0. But wait, there's more. There's one more. Well, there's one more for today. There's one more rule, and it's the parfait rule, the power rule for exponents. And here's Donkey. I didn't have a clip of him saying, everybody loves a parfait. He does say that in the movie, as you know, but he also likes this boulder. That's a nice boulder. Anyway, the parfait rule. So we are going to derive the parfait rule and figure out how it works. All right, let's say we're using one of the other rules above for this one. We have x times x times x. What do you get? You get x to the third. We just went over that. Or x in parentheses to the third. It's basically the same thing because you're cubing everything that is inside the parentheses, which is just the x. Okay? So that part makes sense. Now, what if you have this? Take a look at this one. X to the fifth times x to the fifth times x to the fifth. What can you do with that? Well, can you do this, x to the fifth, but the whole thing cubed? Yes, you can, because this is no different than, doing this. X times x times x is x to the third. This times this times this is this to the third. That is part of the parfait rule. So that part makes sense, right? But we also know how to just figure this out, right? If we just figure this out, it's the product rule. So if you have the product rule, remember, is x to the m times x to the n. And what do you get? You get, you get x to the m plus n, right? So you just add the exponents. So if you just add the exponents here, what would you get? You would get x to the 5, 10, 15. You would get x to the 15. So now, this is what's the cool part. Dun, 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 dun. Now we know that this must equal this, because they're both perfectly valid ways to write it, right? So we can do x to the fifth. This is really starting to bug me. X to the fifth raised to the third power is equal to x to the 15. So when you've got parentheses and then another exponent outside of it, what is this telling you that you do with it? It's telling you have to get 15. You're going to have to multiply those. So that is the parfait rule. So when an exponential expression is raised to a power, we simplify by multiplying the exponents. And we call this the parfait rule. So this is in a thought cloud. So you have to know the parfait rule. You got to know it. It's got to be burned into your brain. It's got to be dripping off your tongue. The parfait rule. If m and n are real numbers, m and n are real numbers, and x is not equal to 0, then x raised to the m power, the whole thing raised to the n power, is equal to x m times n. Bam. Roger that. We got it, right? You got it. Yes, we got it. Let's practice it. If you got it, then we got to practice it. We're going to start with these easy ones. A to the 5th, the whole thing raised to the second power, is going to be what? A 5 times 2 is 10. A to the 10. Okay, what about B? B, we have x raised to the negative 4. It's getting trickier. All raised to the negative 2 power. We're going to have x raised to the, what's negative 4 times negative 2? It's going to be a positive 8. There you go. All right, what about this next one? M raised to the negative 2, the whole thing raised to the positive 4. You're going to have m raised to the negative 2 times 4. What's negative 2 times 4? It's negative 8. Okay. Let's do D. D is P raised to the negative 7, all raised to the negative 7. If we multiply those exponents, negative 7 times negative 7 is positive 49. Whoa, that would be a huge number. That exponent is humongo. Alrighty, what about the next one? X to the 3rd raised to the 5th. A throwback to the easy ones. 3 times 5, 15. Easy peasy. What about the next one? Ooh, it's a little tricky because there is a variable here. M raised to the K, the whole thing raised to a 2. It's going to be M raised to the K times 2. Let's write it 2K because I like that better. Oh, Danny just walked in and he is looking sharp in his suit. Looking very sharp, dude. You look great. Fantastic. Love you, Danny. Bye. Okay. So that's it. That is the rule. Now, did you have fun with those easy ones? Good, because the easy ones are over. What do we do with this? Look at this. This is ridiculous, right? What do we do with that? Okay, the trick is to realize that what we're saying here, when you've got this whole thing raised to the 3rd power, is you're saying this times this times this. That's what you're saying, right? So then you can multiply that out. We're gonna show you the long way first, and then we're gonna show you the easy way. But the long way sort of explains the process. So it's important. Don't skip ahead. Don't skip ahead. This is gonna be great. All right, so the long way is to multiply everything out. All right, so here we go. You've got 3 2's. You've got a 2 here, a 2 here, and a 2 here. And that's why I did 2 times 2 times 2. What else do you have? Well, you've got an x to the 5th, an x to the 5th, and x to the 5th. So it's going to be times x to the 5th, x to the 5th, x to the 5th. What else do you have? You've got, let me get a different color, y squared, y squared, y squared, y squared, y squared, y squared. What else do you have? You have a z. I didn't change it. You have a z. Z, z, z. Z, z, z. Okay, so that's the whole thing that you have. These are all the factors of the product. And this is, if you multiplied this out and had values, you would get the same thing as if you multiplied that out. So this is perfectly valid way of doing it. But of course, you don't want to leave it like this. So what is this basically saying? You're saying that you've got 2 to the 3rd because this is 2 to the 3rd. You're also saying you've got x to the 5th raised to the 3rd. Why am I saying that? Because I've got x to the 5th, 3 of them. So I can do that and raise it to the 3rd. Okay? What else do I have? I have y squared y squared all raised to the third. Why am I saying that? Because I've got 3 of them. 1, 2, 3. And the last one, I have z, and I can just put z to the third because there's 3 z's there. So that's how you simplify it, which basically, if I do the math here, what is 2 raised to the third power is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So I have 8. Then what about the x? I have x to the 5 times 3, which is 15. Then I have y to the 2 times 3, which is 6. Then I have z cubed. And this is the most simplified answer. So we can stop here. Okay? But if you look at the original one, you can get sort of the same answer by just doing all those middle parts in your head. So let me show you how. You would have to apply this 3 to every single term inside the parentheses. So it would be, 2 raised to the cubed. 2 times 2 is 4 times 2 is 8, so I could just put an 8. Then you have x to the 5th raised to the cube, so in your head you could just do x to the 15. Then you have y squared raised to the cube, so 2 times 3 is 6. Then you have z raised to the cubed, and then you could just do z cubed. And then look, without going through all of that, I got the same thing here as I did here. So you should know what it means. It basically means 3 of these expressions, and if you multiply it out, you'll get this. But you can also just use the parfait rule to make it simple and get this for your answer. Okay, so now let's do some, well, where am I now? Let's see. Oh, okay. All right. So it's basically saying that some of the ones we did are very obvious, like those first ones that we did, very obvious. I think you can figure that out and just multiply the exponents. But it also says that to raise a term that contains no indicated additions, so you have no, like, you don't have this nonsense going on, like inside the parentheses, right? It's just everything's multiplied. So you have to have no indicated additions to a given power. The exponent that is indicated is multiplied by the exponent of every factor of the numerator and the denominator if there is one. So there wasn't a denominator here, but there could be. There could be a denominator. And you notice that there's no sums here. There's no like 2x to the 5th plus, there's none of that nonsense. So that would probably change things. So here we go. Let's do some more examples and make sure that we understand it. So this is example A on page 216. If you want to follow along, you have this very complicated equation all raised to the -2 power. So let's just apply that -2 to every term inside, one at a time, okay? And we can even write it out. This is what they did. So it's going to be 3 raised to the -2. Then you have x to the -2 raised to the -2. Then you have y to the 5th raised to the -2, okay? And on the bottom, what do we have on the bottom? We have a z to the 4th raised to the -2. So this applies to this as well, okay? And then if we multiply all of that out, then, okay, what happens to this 3 to the -2? This is what they did in the book. They moved it to the bottom and changed the exponent. So it would be 3 raised to the 2 down there instead of at the top. Okay? Everything else, you can let's just multiply it out. Okay? What about this x to the -2 raised to the -2? So -2 times 2 is just going to be 2 times 2 is 4. So this can just change to x to the 4th. Okay, what about this one? 5y to the 5th raised to the -2. 5 times negative 2 is going to be y to the minus 10. And they just left it on top, but you could make a case for moving it to the bottom and changing the exponent. So they just did that. And then we already simplified the 3, but what about this one? Z to the 4th raised to the minus 2. So 4 times minus 2 is going to be negative 8. So let's change this to Z to the minus 8. And then this is the final answer. Bam, got it. All right, let's do this one. This one looks a little simpler because it doesn't have a denominator, but it ends up having a denominator at the end. So before you get too excited. Okay, so let's take it one expression at a time. Don't forget about the coefficient because you have to do that too. 2 raised to the minus 5. What's the next one? A to the minus 2 raised to the minus 5. Oh, that's really raised to the minus 5. I'm going to make this a little smaller again. Hopefully you can still see what I'm doing. I hope you're not watching this on your phone. Then let's do the next one, b squared. So it's going to be b squared all raised to the minus 5. And then I'm going to have to make myself a little more space. Okay. All right, then I've got z to the minus 10. So z to the minus 10 all raised to the minus 5. All right, so now let's simplify this. What is 2 raised to the negative 5th power? Let's move it to the bottom and call it 2 to the 5th instead of the negative 5th. And then you have to figure out what is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4. There has to be 5 of them. And when you do the math there, you'll get 32 for the bottom. And then let's just simplify all of these one at a time. Minus 2 times minus 5 is going to be a positive 10. So that's going to be a to the 10. Okay, what about this one? 2 times minus 5 is going to be a negative 10. So we've got a b to the negative 10. Okay, what about this last one? 10 times 5 is going to be 50, and it's going to be positive because it's 2 negatives multiplied together. Z to the 50. Final answer. Let's see if it's the same as in the book. Yes, got it. Easy peasy. Let's do the next one. C. Now you know these examples get more complicated, so don't skip ahead. You've got to do these. All right, so now we have a numerator and a denominator, so we have to use the parfait rule, apply this to every single term, okay? So we'll start out with the 4, okay? So 4 raised to the 2 on top, x squared, y squared. What about the bottom? We're going to have m to the minus 2 raised to the 2 power, right? So what's that going to be? It's going to be minus 4. Okay, and then let's just simplify this 4 squared, which is just 4 times 4, which is just 16. 16x squared y squared over m to the minus 4. Final answer. Bam. Easy. All right, let's do the next one, which is D. This one is getting a little more complicated here. Can you see it? It's a little more complicated. So we're going to have, let's start out with the 3. Okay, so we've got 3 raised to the minus 2. Then we have x raised to the minus 2. Then we have y raised to the, and let's just do it in our heads, minus 2 times minus 2, that's going to be y to the positive 4. Y to the 4th. And then that's all going to be over, let's just do this in our head. 5 times a minus 2 is going to be p to the minus 10. Okay, and can we simplify this? Well, because this has a negative exponent there, I'm going to put it at the bottom and do 3 squared. And 3 squared, as you know, is 9. And that's what they got in the book. Bam. Easy. Alrighty. Let's do... Oh, did I? Oh, yeah. I gave myself a lot of room, apparently. But we didn't need it on that one. So let's do this one. Oh, you know what? I see something that I like right away. I see this x to the 0. X to the 0, when it's all multiplied, it's not added to anything. What can I do? I can just get rid of it. X to the 0 is just 1, right? So let's simplify that, and then let's keep going. Now, I'm going to have to do 3 cubed. 3 times 3 times 3 is what? 3 times 3 is 9 times 3 is 27. Y cubed, because I went y cubed, okay? And then on the bottom is going to be k to the 4th raised to the 3. So 4 times 3 is 12. That's it. That was an easy one. That was fun. Okay, let's do another one. Oh, it's our lucky day today. I see something else raised to the 0 power, and it is this. Anything raised to the 0 power is just 1. And you can have as many ones. You can have 15 ones multiplied together. It's still 1. So that's why you can still get rid of that. So let's do this one at a time. X to the minus 2 raised to the 15 power. What is 2 times 15? It's going to be negative 30. X raised to the negative 30. What about the next one? What is 4 times 15? Oh, heck, I don't know because I don't have my calculator, so I'm going to look in the book. It's going to be y to the 60 power. Okay? Now at the bottom, easy peasy, you have z raised to the 15. And if you can read that, that is the right answer. All right. You would think that this lesson would be done because we've done so much already, but no, there is still more fun to be had. And the more fun comes in the form of conversions of volume. So you have to use 3 unit multipliers when you convert volume because, of course, it's 180 cubic feet to cubic inches. And you know what cubic feet means. It means feet raised to the 3rd power and inches raised to the 3rd power. So when you have a power of 3, you're going to have to use 3 unit multipliers. So here we go. We're going to start out with 180 feet cubed, which means 180 feet times feet times feet. We got to get all those feet to cancel out. So how do we do that? Well, I know that there are, I didn't write it out. Okay, so I know, let me give myself more room. We need to convert feet to inches. So what is the unit multiplier that we need to do? I like to do this. I don't know if the book does this, but I like to do it because it makes it easy. So there's going to be, let's see, 12 inches in 1 foot. Okay, now when I do that, I've canceled out one of the feet. But I haven't canceled them all out, and I don't have inches cubed. I only have inches. So I got to do that again. 12 inches in 1 foot. Now I can cancel out another foot, but I still need one more. 12 inches in 1 foot. Okay. And that cancels out the last foot. So now what I need to do, what this is telling me, is I'm going to do 180 times 12 times 12 times 12. Okay? And then I will, so I'm going to have to plug that into a calculator because that is, so it's 180 times 12 times 12 times 12. Plug that into a calculator and you're going to get, actually, you know what? They did not multiply it out. And you can do this in your homework because sometimes they do this on the answers as long as you show me the what you have to do to get the answer, because that's going to be a humongo number. And then don't forget the units. You cannot forget the units because that was the whole point of this problem. So I have inches, inches, inches. When there are 3 of them, it's going to be inches cubed. And I know I did it right because inches cubed is going to be a volume. Okay, let's do, oh, there is no next one. Oh, wait, there is one more. One more. Last one. Last one. Use 6 unit multipliers to convert 800 cubic centimeters to cubic feet. So we started out with centimeters cubed. We want to end up with feet cubed. Okay, so here I started the problem. 800 centimeters times centimeters. Now, in order to convert it to feet, I'm going to convert it to inches first because I don't know how many centimeters are in a foot, but I know how many centimeters are in an inch. And since I have centimeters on top, I'm going to have to put centimeters on the bottom in order for them to cancel out. So I know that there are 2.54 centimeters in 1 inch. But that is only going to cancel out one of these centimeters. So I've got to do that again. 2.54 centimeters in 1 inch. 2.54 centimeters in 1 inch. Okay, so now I can cancel out centimeters. Whoops. Centimeters, 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 centimeters. And now how do I do this math? You have 800 divided by, because these are on the bottom, 2.54, and another 2.54. Okay. And what are my units? Inches cubed. Because of this, inches, inches, inches. So I have inches cubed, but that's not what they wanted. That is not what they wanted. They wanted feet cubed. So now I have to change this into feet cubed. So let's see. Instead of inches cubed, I'm going to put inches, inches, inches. Because those were on top, remember? They were on top. Now I'm going to do another unit multiplier. So I've got to have my thingy. Now, I want to change it to feet cubed. So how many inches are in a foot? And I have to, there's 12 inches in a foot, right? So does 12 inches go on the top up here or down here? Well, it has to go down here because that way the inches cancels out with those inches, right? So I'm going to put 12 inches in 1 foot. Now I've canceled out one of them, so I got to do that again. 12 inches in 1 foot. One more. 12 inches in 1 foot. Bam, canceled. Now, what do I have all together? I have 800 on the top. I have 2.54, 2.54, 2.54, 12, 12, 12. And if you do all of that math, you will get something in feet cubed. And I don't know what that is. And neither does the book, because that's how they wrote it. Alrighty, so that's all you have to do. That's it. Not a bad day, right? Not a bad day. Great lesson. That was super fun. Hope you enjoyed it. Have fun doing your math. Love ya. Bye.